We looked at 6 lakes in the state, and we partnered with different drinking water districts. So all 6 of these lakes are drinking water sources. We were interested in trying to understand how storms affect these lake ecosystems. And in particular, we're trying to understand how something called dissolved organic carbon is changing in Maine's lakes. It's actually one of the most important substances in lake ecosystems, but it's not talked about that often. So dissolved organic carbon is a natural material. It comes from the forest, essentially, and from soils. It comes as leaves and needles degrade, for example. And the concentration of that material has been increasing in lakes of Maine over the last 2 decades or so. And we actually think that's a good sign. We think it's recovery from acid deposition. But there may be another driver involved here as well. And we know that the frequency and severity of storms has been increasing over the last 60 years in Maine. And so we're trying to understand to what extent do those storms play a role in these increases in dissolved organic carbon. Dissolved organic carbon is important in drinking water lakes because it can interact with some of the treatment processes that drinking water districts use, and it can actually then form some harmful byproducts. So it's important that we monitor what's happening with this material so that we can adapt our treatment strategies if needed with storms. There were really 3 different patterns of response. We found that some lakes showed no response to storms. They're actually pretty large lakes, they hold a lot of water, and storms don't have a big impact on them. But then there were 2 other categories of response. We saw a sort of flashier response where right after a storm there was a big spike in dissolved organic carbon, and after a few days it declined back to the same value as before the storm. And then we also saw what we called a sustained response, where we didn't see as big of a spike in those systems, but we saw that the concentration of DOC increased and it stayed higher after a storm. And so that type of information can be useful for the water districts because they can understand whether they'll need to modify their treatment strategies with storms.